events today. One is in IIT. I think both Professor Munira and Professor Tabassum had attended that ATC 1.0. You also have a 1.0 here. And now today morning 2.0 was launched. And I was asked by my chairman, would you like to be there or here? So, of course, what choice I made. And because the reason was I get to address much larger audience, much younger audience who is happening. I think there was a question in the morning session. By the way, the morning session, the first batsman, I think some of you, he was mentioning 2050. I'm mentioning to you about 2020. I think those who understand what is cricket 2020, there was a gentleman called Sanat Jayasuriya, some of you may know, some of you of my generation people would know Sanat. He was like Sanat Jayasuriya, and he has set a tone for the speeches ahead. And we have to sort of match with what he has set the tone for a 2020 match. So there was one more thought that I wanted to mention, that there is this thing called infotainment, information and entertainment. Because often at times when I used to take theory subject, like, one of the subject could be like refrigeration. How do you extend the shelf life of perishables, for example? So in that, let's say I would tell them about the design of, refrigeration system, vapor absorption system, vapor compression system, that these are. And, often at times since last 10, 12 years, the kind of body language the students used to show me that, what is in it? We already know about it. Google tells us all about this, the diagrams, how the fluid is flowing, how the temperatures are created and all. Tell us something more. Tell us something new. And so there, for example, particularly in my domain, the technology and development, instead of how things work, or how know how, they would like to know why and know where. So know why is like the rationale. Why are you trying to talk about this technology? Let's say in refrigeration, we had thing called pre-cooling systems. So like you have the coolers, or let's say a cold storage system for dairy product, or cold storage systems of fruits and vegetables. There will be something which is called pre-coolers. Like, if the grapes are exported, table grapes from here to even European countries, some of you may know that European countries produce lots of winery vineyard. They have wine grapes, wine quality grapes they make, but table grapes are exported from here. Now when the grapes are going to come from 300 kilometers, a place called Nashik, from there to here, you need to pre-cool them. During the transport, like your milk, for example, the milk which is pasteurized, which needs to come here, and by the time it gets delivered, it still needs to have that 4 degrees Celsius, 3 degrees, between 2 to 4 degrees Celsius. So now, how do you transport milk at 2 to 4 degrees Celsius? Is a science, is a engineering there, for example. So something which has, why multidisciplinarity again is like this knowledge came that pre-cooling is required is from post-harvest physiologists. The post-harvest physiologists told that 25% of the losses happen if you do not store it after harvesting for first 10, 12, 15 hours. During that temperature, you would have already lost. So then, for example, so know why comes there. So I have to tell this to students, why do we need to design cold storage systems? What is it that we can learn from sciences? How do engineers sort of, so we always say the scientists explain what it is, and engineers make things to sort of, use that knowledge to sort of, construct and deliver to make things work. So let me come to my, I can use this, right? I can use this. So this is something I'm sure some of you would have, if not the students, the professors would have sort of heard about this great guy called Hippocrates. In the history, he says, let food be thy medicine and medicine be thy food. So I come from a discipline of food science and engineering, and I was wondering what should I talk in a conference which is organized at a pharmaceutical college, and there's, a large doctrine or the statement. If this guy had said, and I think this is in ancient times that proverb had come, an apple a day keeps the doctor away, right? Somebody was asking in the morning how many chemicals you have in aloe vera, I think was said 58. and then 108 in sort of, different material. Apples, for example, have something like 50 phytonutrients, and that's what made people write, I think, people in the domain of arts or English literature said that, an apple a day keeps the doctor away. I'm not sure whether the same phytonutrients will be found in the apples today, but we sort of do know this. So what I'm going to talk, or the slides, Professor Tabassum, I'm going to give these slides to you. Not everything is written in the slide I'm going to read to you. So what we are saying, like what most of the things that I have got is some mix and match of what is known from the science of nutrition, science of food, and science of wellness that you have. So a typical food science and nutrition department or discipline would sort of now offer you a sort of, a syllabus or curriculum which will talk about clinical nutrition, then food science principles, human physiology. Also, they have to learn that in a food science course. Analytical techniques, food preservation and processing. I just talked to you about refrigeration. There are other thermal and non-thermal processes. I'm not going to tell you more about that, but that's part of the syllabus. Of course, then research and development, like NPD, somebody talked about in the morning, new product development. A food inspector, you all know that there is a role of FDA, like Food and Drugs Administration. So in that sense, I saw there is a commonality between what pharmaceuticals professionals and what the food industry professionals do. Both are regulated by an agency called FDA. And in our country, I think some of you know that for foods, we have a institution which is called FSSAI. Any student has heard about FSSAI? Yeah? What does it stand for? Yeah? Yeah, Association of India, Food Standards and Safety Association. And under this apex organization, you have each state has a FDA. Mumbai's FDA is in Bandra Kurla complex, some of you know. So that's the food inspectors you have. Then you have so this is like, professionals which are created using this sort of, domain of sciences. So you have dietitians, nutritionists, quality control. QA, QC is something which in food manufacturing, an important function, QA and QC. Of course, as a pharmacist, you will be sort of not working in these areas, but you would be surprised to know that in European countries, for example, the entire regulatory of animal sort of, food sources is handled by veterinary graduates. Entire regulation is handled by them. So, so food, nutrition, wellness, of course, what have we learned from the science, whatever we call it as, research-based outcomes of sort of, so that you need to have a diverse diet. And some of these must be old principles that our ancestors used to tell that millets are good for you. And now some of you would know that this is an international year of millets. All our ancient wisdom is coming back. That is what I was trying to tell earlier also, that chemistry is nothing but all those Pancha Mahabhutas. So like that, food, diet, diverse diets is something. Do not converge on only two cereals. What we see, what was our lunch, for example, the two cereals. Anybody names the two cereals that we ate at the lunch? Rice and wheat, right? So we have converged on these two, and there is sort of, international wisdom now that millets have something good, something called fiber, something called, vitamins, so, and other nutrients. So you have to sort of respect to that, give respect to keep your food diverse, so that, you get all those sort of, benefits. And then malnutrition, I think some very, very cursorily somebody mentioned that in spite of would we being the country being food surplus, that whatever we have 300 million tons of cereals, about 330 million tons of vegetables and fruits, and about 80 million tons of dairy, eggs and all that, there is still a great, a considerable portion of population is still facing the issues of malnutrition. And the major types of malnutrition are, you have both micronutrient, which is vitamins and minerals. I was told, Professor Munira Munim, that something like 25% or 30% of our women are still suffering from anemia. I don't know, this is what NFHS and the data indicates, but I think this is something to believe. The data has been sort of published in NFHS 2011. The next NFHS round is not as out. But you see, for example, we are still sort of, although in spite of knowing the importance of these, micronutrients like, minerals like iron, calcium and all that, gives you, inadequacy gives you a symptom like anemia and all that, but we are still, so there is a role, there is something that, the food science, nutrition people need to sort of, and therefore, I think Aditi has left the conference now, or Aditi is still there? One who was asking, she has left. Oh, she's still there. Yeah, you will now realize that the importance of such conferences, You don't have to hide your face. No, you were a reason. Huh? She's preparing for her questions. Yeah, so in the sense that, this is what explains why do we need ingredient conference and natural conference. See, iron folate tablet, some of you may know that it is given by Government of India through ICDS to every pregnant woman, almost free of charge. I think it still continues to be given, iron folate tablets. And mostly in rural areas, you have that kind of a malnutrition, because what we say that, in the literature you will see this is kind of a vicious cycle. You don't have to travel that far. You just go 100 kilometers. There's a place called Palghar, new district of Palghar, which is about 90 to 95% are tribals. There, the young woman is still married at the age of 16, 17, 18. She is malnourished. She delivers a child within a year or two of marriage, a malnourished child, and then the vicious cycle continues. So this is something which, of course, me as a IIT professor till 2010, for example, 2010, I was into my books and I was into my silos and I would just deliver my lectures with slides one. Somebody from Minneapolis, working in a company called General Mills, had to come one evening to my cabin and tell me that, have you seen malnutrition in India? Have you formulated any food products? I said, no, which malnutrition? India is an arrived country. In 2010, I said this. India is an arrived country. We don't have malnutrition. Then what he did, it was 7 o'clock in the evening. We walked in the office of pediatrician of IIT Bombay in IIT Hospital. I happened to know her because she was my neighbor. And until the time this food engineer from General Mills working in Minneapolis not only showed me the data of NFHS and the kind of malnutrition that is existing, but he made me talk to that pediatrician, and the pediatrician working in IIT Hospital, she said, both of you are right. Professor Shah is right because in IIT there is no malnutrition of the kind which he is mentioning, and he is right because that is something. So what she did was immediately she called up Sion Hospital. Some of you may know Sion Hospital is in the middle of Dharavi, right? I mean, close proximity of Dharavi. And she said that here is head of the department, pediatrics. I'm taking an appointment for both you, Professor Shivram Murthy from Minneapolis and Dr. Narendra Shah from IIT Bombay. Will meet you and will make you understand what that malnutrition is. And I walked with Professor Shivram Murthy to this Sion Hospital, and she showed me the ward of this Nutrition Rehabilitation Center. And, I think the story went that, 2011 onwards, I took up this as a challenge of formulating food for malnourished kids. So in that, there is a great deal of science, which comes from medical sciences. There you call, SAM children and MAM children. SAM is severely acute malnourished. MAM is moderately acute malnourished. And each of these sort of, categories have their own requirements. What they say is a SAM child, for example, has 9 times more mortality risk than a normal child. A MAM child, for example, has 5 times more mortality risk. Now, how do you get that child which is suffering, which is less than sort of, 2 years? How do you, or less than 5 years, for example, how do you take it within a window of that 2 or 3 months when the child is brought to the Nutrition Rehabilitation Center? What is the kind of food you can formulate? So then we, for example, we looked into the literature and we said that, I was told that there is some gold standard in terms of how do we fortify. That's why my topic is like, food to food fortification. So we formulated a sort of a baby food, which was, for example, for the children which were less than 5 years, because then we had various elements that went into design of such formulation. One is it should be palatable to a kid, right? So it had to be something like a consistency of ice cream. It had to be a cream or dahi kind of a thing. Second was, for example, you had to sort of mix those 19 micronutrients, which the pediatricians have established in terms of science that what causes malnutrition. So you had not only these vitamins, different A to E, but also you had minerals like even zinc, for example. So zinc was important in giving that effect on height. If you are deprived of zinc in that particular age group, you are deprived. So it's a lot of those things are also in plant sciences. Then I started linking to it, that if the plant which has a sort of, grows in 6 months, if you do not provide that NPK and other minor elements to it, that it will be lacking in terms of. So that gave me a lot of what you call, and quite a few of my publications are on those, how to address, because one was then, this factory made paste, which was called as RUTF, which is called as ready to utilize therapeutic food. Okay, so this is something which is manufactured. So if you are in Palghar, in Jawahar or Mokhada region, you don't have a factory there which makes this RUTF. You may have something. We then, of course, set up a factory manufacturing unit in Dharavi, which is a part of the Sion Hospital, because that was the condition of that head of the pediatrics department. She said, okay, you can show me the literature, but I will allow you to do your clinical trials only on the condition that you will manufacture your formulation right in our backyards. So she gave us some 300 square feet area and gave that challenge. So we had to put up those equipment. How can we sort of, and then like, once you formulate, I think somebody mentioned about shelf life, it has to sort of have a shelf life of 6 months. Because, once you make it sort of, the Anganwadis, for example, there in Dharavi or any other place are not going to immediately give it to the children. So it had to have a shelf life of, then how do you pack it? What is the kind of, so all those packaging and then stability. For example, because it was a peanut butter based formulation, the oil got separated. In the initially when we sort of made that formulation, we saw that the oil was separating. Then we had to sort of, work towards it. The size, the little kid, what is going to absorb, so that it turned out that the particle size has to be less than 200 micron. So all that science went to it, the bioavailability of those nutrients, uniformly spread of that nutrients, what kind of equipment then that go into it. So all that. Okay, so food fortification, if you look into the literature, I said the WHO, World Health Organization, has defined it in this way, that food fortification is the practice of deliberately increasing the content of an essential micronutrient, vitamins and minerals, including trace elements in a food, so as to improve the nutritional quality of the food and provide a public health benefit with minimal risk to health. So when you say nutritional quality, it's not just measuring, doing your sort of, elemental analysis and, laboratory analysis. You also had for clinical trials, for example, have to establish those bioavailability and things like that. So those, and then subsequently again in the literature you see the definitions of food to food fortification. This is an approach that uses an interesting, available and accessible local resource. It's calling local resource, you see, plant or animal containing useful amounts of micronutrients to fortify other food. Anybody can give me out of students an example that you see this day in, day out, that our Indian food systems do fortify, our foods using something. Can somebody give me one example? Yeah? Right. So for example, in US, for example, thank you. In US, it's obligatory that all milk is fortified with vitamin D. Not in our country, we don't need it, because there you have a issue of they are in temperate climate, so they don't get enough sunlight. We have good amount of sunlight, so vitamin D synthesization by our body is not a issue, but there it is. So all milk or dairy is fortified, and all dairy are obligatory. But other simple example is moringa leaves, moringa drumstick. Have you all heard the nutritional quality of drumsticks? And look at our tradition, any sambar that our South Indian friends and families make, it has to have drumstick, right? So that is food to food fortification. Some simple examples of that. So it is given here, addition of moringa drumstick leaves in infant complementary food improved its nutritional quality. Addition of mushroom powder in the wheat flour improves the protein quality of the food. And addition of curry leaves, simple curry leaves that we see here in fermented batters such as idlis to improve the micronutrient density of the cooked product. So these are some of the examples, and I think we should sort of, while we have this sort of, know-how or knowledge from the advanced science or modern science as we call it. So this is something which I'll leave this figure, I'll not deal with it, but you see, for example, there is the role of all these enzymes and how sort of, parametrics in terms of pH and all this, and how do you sort of get to those food component in a manufacturing kind of a scenario is given here. So imperatives of food processing and delivery systems. So you have synthetic micronutrients are unstable and need, so there is something wrong with synthetics also. In the morning we talked about, synthetic is all good, not only side effects, but it says that synthetic micronutrients are unstable and need protection when delivering through food. So therefore, it's for example, things like microencapsulation. Some of you who would have done labs, I think in your excellent facilities, I happen to see the college facilities that you have. So you can do some nice microencapsulation of these essentials. Avoid precipitation, improve solubility, reduce any chemical reactions. Oxidation is something which, so if you look at what spoils food really, so oxidation is one of the things, the oxygen that is in the 21% in the ambient, that sort of, spoils, you get lots of rancidity and other kinds of things. So when you say that shelf life has to be there, so that as principles, I'm not going to get into really a theoretical lecture here, but water molecules, so water activity, I think some of you would have, in a food chemistry class, would have understood what is water activity. It's little different than what moisture content. So water activity is one which spoils the food or pharma product, or which constrains your shelf life, and another is oxygen, for example. So these are all biochemical reactions which happen. Reduce detrimental interactions among micronutrients in case of multi-micronutrient delivery. So anybody has heard about fortified salt? Suna hai? Tata namak? Suna hai kisne? What is it fortified with? Iodine. But people tried double fortified salt. Anybody has heard of that? Huh? So they tried, for example, so this is like multi-micronutrient, they want not only iodine, but they wanted some iron also to go with it, because to address the anemia, because salt is something which everybody we eat. So can we? So there are some challenges, so I think I'll not get into this. These are some kind of parametrics, and I think you will be able to see. Important thing was I said about bioavailability, and bioaccessibility. I think these are two important concepts. Can you just click this blue, this blue here? You see, for example, you can sort of do, we have heard about in vitro, in vivo. When you try and do your M.Pharm, and when you have to give your thesis, you have to produce your thesis, you will come across these methodologies, like how do we sort of, do the in vitro studies and in vivo studies, for example, to establish its, bioactives and things like that. So there are some methods of doing in vitro studies, and you sort of use some analytical instruments like HPLC, UV-VIS, fluorescence, ELISA and all that. So can you go back? So this is something in vitro is you do in your lab basically. Vitrine in French means glass. So you do something which so whereas in vivo technique, you just click this here. That is something in your rack models or as you can see here, for example. And I think your college has these facilities, right? the in vivo studies which you do before you sort of, get anything which is approved by FDA, you have to do the efficacy test using in vivo methods, and what normally you do it with the rats. I heard recently that fisheries people have come out with some zebra fish, which sort of, gives you faster results in your in vivo studies. So next slide, please. Yeah, so techniques of micronutrient delivery. So I just talked to you earlier about micro encapsulation. Then you had emulsification. I told you about when we made this RUTF as a food to address malnutrition of SAM and MAM type. So there the oil and fats were getting separated. So we had to use emulsification technique or emulsifiers, which are approved emulsifiers, for example, for food. Nano encapsulation is another where only size of the particle size plays a role, but apparently if you go to a further smaller size, absorption is apparently better. Liposome technology, co-observation. So let's go to next slide. Can I take 5 more minutes? Is it okay? Yeah. So like for food systems, the matrix has to be food grade. So always you first thing that you do is anything formulation is there any toxic effect? Something may be a good effect, but like, whatever the side effects that we talked about in pharmaceutical formulations, I think it's the same methodology that we adopt in foods also. Sort of we see that if there is something which is not giving you anti-nutritional factors and things like that. So food matrix compatibility, protection ability, dissolution at desired location, process to be robust and reproduce. This is something which is like, imparts any industrial character to the product, that it has to, your process has to be robust and reproducible. So whether you have done a manufacturing of a chocolate Kit Kat on Monday or Friday, it should give you the same sensory feel or sense, whatever nutrient it had. Next slide. So this talks about some techniques of how do we sort of, go do homogenization, emulsification, because this is something what we typically call in engineering as unit operations. So once we know the science, I told you about engineers, when they understand things which are devised or explained by scientists, then how do we sort of how do you make it? So then there are various techniques of spraying, spray drying. How do you get those uniform products? As I said, from batch to batch, you need to have that sort of, validation and something, I think Abhishek gave that word as a mixed whatever crystal. So crystallization is an important sort of phenomena. It gives you solubility, it gives you sort of, different in the formulations of whether it is a nutraceutical or a food product or a pharmaceutical product. Next slide. So this actually is just giving you a flow diagram of how a spray dryer would work or would look like. So again, I would not go into the details, but it's something which is available on Google. If you just Google how does a spray dryer work, and it will tell you sort of, next slide. So these are all different unit operations. Extrusion is another, unit operation where you push something at a pressure and process it through temperature. So you get temperature pressure effect to get some kind of your capsules or the extruded products. Anybody knows a very commonly used by youngsters, particularly a product which is extruded? Kurkure. Another one? Pasta, right? So it's cold extrusion. So many people have objections to temperature in the extruders because product gets cooked and they say that, vitamins are lost, they are not heat liable and things like that. So you have a cold extrusion, and pasta is the right example. Ma'am, you seem to have a food technology background. So, yes? Right. Yeah, next one. Micro encapsulation of micronutrients. I think I will not talk to you about core and sort of, the wall material and the core material, what you want to use as core. So there is a lot of science in that, or there is a lot of, particularly because when you want to do encapsulation efficiency, entrapment efficiency and things like that. So this is, I think, I'm sure, taught as a part of the course in formulations. science. So of late, when people have been talking about nano encapsulation of micronutrients, I know that ma'am herself has produced nano gels. So this would be covered in some of your. So this is a table which gives you sort of comparative between what is micro encapsulation, nano encapsulation, the challenges of delivering this, and the goodness of using those. So I think I'm almost coming to the end. We have said this food to food fortification, substituting staple flours of cereals, millets with herbs, extracts, dried leaves, legumes, flour. Some of these I think we have been practicing ourselves. So what I used to challenge these PTech students at IIT when I taught this course on Introduction to Food Process Engineering, said that, okay, it's fine you like pizza, The question is, how can you make a nutritious pizza? You just eat a simple pizza, perhaps it's not enough. Can we have sprinklers? So a sprinkler type of a product which has the micronutrients embedded in it. So use it as a topping. So that's the challenge of nutraceuticals. Banana peel, for example. Only Sion Hospital told me that if you have a burn, for example, you can use banana peel. Somebody was telling me in the morning class about bananas, micronutrients, banana as a ingredient. But here banana peel also is useful because it has fiber, potassium, vitamin A, and all this goodness. So you can make banana peel chutney. I think some of our people, Bengalis, for example, if anybody is Bengali in our group? You have a Bengali. Have you heard of banana peel chutney? Yes. How do you call it in Bengali? You have eaten it, okay. So it seems there is some goodness in that banana peel chutney. Watermelon rind. See, there is huge quantity of watermelon rind, for example. You can also make watermelon rind chutney, and I think all this has been sort of evidence through modern science that the watermelon rind can give you this. So this was the reference material which I used in my sort of teaching course, and part of that I have brought it here. Thank you so much.